Hi, I'm Charles Bailly, a human-computer interaction researcher working at Immersion. Today, I will present you our own use case and the network application we developed within the Evolve 5G project. The complete name of our use case is Remote Assistance in Augmented Reality for Industry 4.0. And to better understand it, I would like to start by coming back to this notion of augmented reality because there are many coexisting definitions and concepts relying around it. To keep it simple, we often use the terms mixed reality or extended reality when there is a mix of virtual and real environments and objects. This includes adding holograms in the real environment, for instance, like you can see here on the left. This is what we call augmented reality because we add virtual information into the real environment. On the opposite side of the spectrum, we can completely immerse the user into a virtual environment, as you can see on the right. In fact, the notion of mixed reality regroups all these technologies. So what I just mentioned, virtual reality, but also augmented reality and everything in between in this continuum between real and virtual. Today, for now, our use case is mainly focused on augmented reality, and this is what I am going to talk about. Immersion has been working on this kind of technology since 1994. We are a French SME located mainly in Bordeaux, with a large panel of activities around mixed reality and collaboration. We propose hardware headsets, our own tactile tablet, for instance. We conceive also immersive spaces with our own software solutions. We also participate in the industrial and research projects. And one of these research projects is Evolve 5G. On the main application domain we target at Immersion is remote assistance. Let's take an example. Imagine a worker within a factory who has to repair or inspect a complex machine. Instead of relying on a cumbersome paper documentation, the worker can put an electronic headset to view virtual guidance objects. It could be written instructions imposed directly on the machine, videos to showcase the specific procedures. It depends. In this case, augmented reality is already a powerful tool to easily access to virtual content. However, sometimes it's not enough. In most complex cases, the worker may need some support from an expert. And this expert is not necessarily inside the same factory or even the same building. But thanks to augmented reality, they can still collaborate remotely. Such collaboration includes seeing what the others see in real time, manipulating shared virtual objects, for instance. However, to guarantee a fluid collaboration in real time, we need the appropriate network infrastructure. And this is where 5G comes into play. Because 5G has a strong potential for such applications and contexts. First, it may be usable when Wi-Fi is not available, which is often not the case within factories. Secondly, 5G also offers performance levels in equation with what we need for real-time collaboration in augmented reality. This is not necessarily the case for 5G, for 4G, sorry. Last but not least, 5G network also offer additional services like network slicing, which can be interesting for our use case. Let's enter a little bit more into details. We can split the components of our network app in three categories. On the left, we have our vertical application instances running respectively on an augmented reality headset and a laptop. They are pre-existing applications developed by Immersion to handle all the reality aspects and the remote assistant features. They were developed in the C# programming language using the Unity framework. On the middle, here in green, we have the network application from Immersion. This is a Python application that we developed during the project, and that I'm going to detail a little bit later. Finally, on the right, we have all the 5G core components, which include everything related to NEF, CAPIF, and TSM. As you can see here, the network application can be used as an intermediate component between the vertical application and the 5G core. It handles high-level requests from the vertical applications, translate them into API calls to 5G core components. Then it translates back the answer into a high-level form which is understandable for the vertical application. This is the basic behavior of many network applications within the Evolve5G project. The network app for Immersion is focused on monitoring the quality of service, which is often called QoS for short, so the QoS of a 5G network. And by quality of service, I mean the level of performance the network can offer in terms of latency, bandwidth, and so on. Here, the idea is that we can notify our end users when this quality of service is degraded. However, the real added value of our network application comes from the service adaptation it proposes. When the quality of service changes, the network application is able to autonomously compute which remote assistance features could be affected. Thanks to that, it can send a set of recommendations to vertical applications to offer optimal compromises between the available features and the limited quality of service. The vertical application then can take this recommendation and they will be able to decide which one they want to perform internally and how. For instance, when the quality of service is somewhat limited, the network application will suggest to temporarily stop the synchronization of the shared augmented reality virtual objects. This way, we preserve the bandwidth for video and audio communication. And if the quality of service is really degraded, we also disable video streams to keep the audio, which has the highest priority for end users. Overall, our system facilitates the collaboration between the local worker within the factory and the remote expert. One of our main goals is to limit the confusion and guidance error by informing these users about network issues. It also has the advantage of being transparent. End users do not have to do anything because all service adaptations are automated. Finally, the network application from Immersion is not tightly coupled to our vertical applications. Other augmented reality developers can obtain it by downloading it for free on the online Evolve5G marketplace. This way, they can benefit from it or even complete its features to match with their own vertical application. We hope that this will facilitate the access to 5G and its adoption into other communities. Through this video, we have seen another view of the network application developed by Immersion and the augmented reality use case of this network app. You now have more knowledge about the potential of 5G for augmented reality and remote assistance. To go further, feel free to visit the Evolve5G website, the Immersion website, or other Evolve5G courses available in this platform. Thank you.